Here we're given a diagram and asked to solve triangle ABC. So here I see three circles, and in the center of each circle I see A, B, C respectively. And then I'm given some information, right? I see three other points, E, F, and one that's not labeled over here, which I would assume is D, but apparently we don't need to know that. And I'm told that the distance between A and E is 5.06. No units given, so 5.06. Over here, I'm told that the distance between C and E is 7.59. So I see these as radii, right? I'm given the radii of these circles. Well, if that's a radius, that means this distance over here is also a radius, which means that's 7.59 as well. And then in my third triangle, I see that the distance between B and point F is labeled 3.18, which means this radius is also 3.18. And to kind of complete the story, the one missing piece over here, well, that would also have to be 5.06, the radius of that circle. And so what I see now is a triangle where I have enough information to write down the lengths of the three sides, meaning I'm really just solving a side-side-side triangle. And so if I think about it, side A over here, across from angle A, well, that length would be the sum of that 3.18 and 7.59. So side A's length, 3.18 plus 7.59, comes to 10.77, whatever units we're dealing with. Side B, across from vertex B, 5.06 plus 7.59. Side B is about 12.65 units long. And then finally, side C over here, I take the 3.18 and add the 5.06. And I find out that side C is about 8.24 units long. So in looking at these as radii and labeling it the way we did, we find out that we're really just trying to solve the triangle where A is 10.77, B is 12.65, and C is 8.24. We're just solving a side-side-side triangle. All right, so we will proceed using the law of cosines, and I want to find the largest missing angle first. Well, that's across from the largest side, so that's going to be this angle B, angle beta. All right, so I need to know the law of cosines written down if I'm going to try to find that. So that's going to start with a b squared is equal to a squared plus c squared minus 2ac cosine of that angle beta. Let's plug in stuff where it goes, and we'll be well on our way to solving this triangle. All right. Two times the 10.77 times the 8.24 times cosine of the angle I'm looking for. All right, I'm ready to find beta. So I have 12.65 squared, and instead of writing down that number, I'm just going to go on and imagine taking away those squares as well. So I'm going to take away 10.77 squared, and I'm going to take away 8.24 squared. And that would give me minus 23.868, not rounding at all here because I don't want to lose any information at this point. All right, in front of the cosine, I have minus 2 times 10.77 times 8.24. So minus 177.4896 times the cosine of beta. All right, I'm just going to go on and find what beta is. Or I need to imagine dividing both sides by the minus 177 point whatever, so minus 23.868 divided by minus 177.4896. And that's what cosine of beta would be equal to, so let's go on and take the inverse cosine. I know I'm going to get an acute angle here, 82.3 degrees. So we found beta. We found this angle up here at the top of our triangle to be about 82.3 degrees. Now we're just left to either find alpha or gamma. Well, I found the largest angle in the triangle. It doesn't matter which one I find next. I'm going to choose to find alpha, and I'm going to use the law of sines. Sine of alpha divided by 10.77 is equal to beta, the sine of beta, so sine of 82.3 degrees over what b is, 12.65. All right, well, let's go on and write down what alpha is. And then finding gamma is going to be the easiest part. All right, there's the sine of alpha, leaving alpha to be 57.5 degrees. And then gamma, well, if I add 82.3 to this, and then take that away from 180, I would get that gamma's about 40.2 degrees. And there we have it. We have found our three missing angles using these mutually tangential circles and their radii. And that's it for now.